All right, so last video for 4.1. So we're going to look at identifying significant results with probabilities. Now we talked about significant results in the previous chapter, in chapter 3, using the range rule of thumb. So that identified some specific cutoffs, and we said if it fell beyond those cutoffs, we either had a significantly low or a significantly high result. But anything in between was considered not significant. We have something similar to that when we're talking about probabilities. So let's just read through this, and then I'll kind of show you a picture that will hopefully give you a better view of what this looks like. So when trying to identify whether or not a value or event is unlikely, we can examine probabilities related to this value. As in chapter 3, we will classify these values as significantly high, significantly low, or not significant. So when a value is classified as significantly low, then we will also consider it unlikely. So it's unlikely to happen if you have a really low probability. That's kind of the way you need to think of that. So if it's significantly low, that means it has a low probability, so it's unlikely to happen. All right, so now what are the cutoffs? What are the cutoffs for significantly high and significantly low? So let's read further. If we have a significantly high number of successes, then that means that X successes among N trials is a significantly high number of successes if the probability of X or more successes is 0.05 or less. That is, X is a significantly high number of successes if the probability of X or more is less than or equal to 0.05, and we can also substitute in 5%. So 5% is where that cutoff is on the high end. And on the low end, it's also 5%. Now, again, I'm throwing 5% out there, but what does it look like? What are you really talking about, Lee? I don't understand. Well, let me read the second one, and then I'll draw a picture. X successes among N trials is a significantly low number of successes if the probability of X or fewer successes is 0.05 or less. That is, the X is a significantly low number of successes if the probability of X or fewer is less than or equal to 5%. So let me draw my picture here. So I'm going to use a number line, and I'm going to start it at 0, and I'm going to go all the way to 100. So there's my percentages, my probabilities. And again, I'm using percentages just because it's a little bit easier to wrap your brain around versus decimals. So we got 0% to 100%. Now, if we wanted to look at significantly high, it says that it's got to be that X or more is less than 5%. So if I were to go 5% down, that puts me at 95%, obviously. But this range here, it would be considered significantly high. So it's significantly high when it's in this window. If it's 5% or less. So I mean, if I was at 96 or 97%, that means it's less than 5% from getting to 100. So again, it's kind of hard to wrap your brain around. So, but it's in this window. So if it was 96, 97, 98, 99, all of those percentages are within 5% of getting to 100. So that's why it's considered significantly high. If I was at 94%, but now I'm in the middle, I'm 6% away from the end. And so that wouldn't be significantly high. And it's very similar on the other end. So if I went 5% out here, again, this 5% window, excuse me, is where it's significantly low now. So if I was at 4%, which puts me, within 5% from this end. So you're always looking at the ends. If you're within 5% of getting to 0 or within 5% of getting to 100, that's where it's significantly high or significantly low. Everywhere else is not significant. Now, the other trick with this is that you're looking at not just an individual probability. That is where it differs from the range rule of thumb. Range rule of thumb, you're looking at a specific number, and if it falls beyond, then it's either high or low or not significant. But for probabilities, you're looking at a batch of probabilities together and seeing if it's less than 5%, not just a single probability. So there's a big difference. So X or more, X or fewer. So let's see that in action here. Now I'm going to erase this because I'm going to use this number line for this next example. Okay, I'm going to put another number line up above it. So let's take a look at flipping a coin. That's a pretty simple concept. Let's flip a coin 460 times. And then the result consists of exactly 252 heads. The probability of getting exactly 252 heads in 460 tosses is 0.0045, whereas the probability of 252 heads or more in that many tosses is 0.0224. Is 252 heads in 460 tosses a significantly high number of heads? Why or why not? So, if I drew a number line right above this, excuse me, and instead looked at it as my number of coins. So I'm going from 0 to 460. Where does 252 lie based on this information in here? Does 252, so again, there's the cutoff for 95%. So where does 252 lie? Does 252 lie over here based on this information, or does it lie in here, somewhere in this significant range? That's what they want to know. And you can determine that not based off of this individual probability. Again, exactly this is that. We can't use that information if we're looking at significance. So this is garbage. But we can use this information. The probability of 252 heads or more is 0.0224, which if we changed it to a percent is 2.24%. So that means that if we went from 100 and went backwards 2.24%, that's where 252 should lie. So 252 would have to be there because, again, it's within 5% from getting to 100. It's 252 or more. So everything above that is a very small percentage. It's less than 5%. So that puts it in this significantly high range. So the answer is yes, it is significantly high. So it is significantly high, and the reason why is because the probability of 252 or more is equal to 0.0224, which is less than or equal to 5%. So again, it's so close to 460, it's within 2% or within 5% really of getting to the end. That puts it in that significantly high range. This stuff is very hard to kind of wrap your brain around. So that's why the pictures are kind of hopefully helping a little bit. But let's take a look at the next one, and hopefully that will frame the whole picture. Is 252 heads in 460 tosses a significantly low number of heads? Hint, what is the probability of 252 heads or fewer? Okay, so if we went back to our picture for a second, 252 and higher is 2.24%. So what's 252 or lower going to have to be? If we use our complements, that should tell us the other side. So if this is 2.24%, then all of this has to be the complement. So this is going to have to be 100% minus that, which is 97.76%. Is that less than 5%? Heck no, it's way too big. So that means that since it's not less than 5%, it's not significantly low. So the answer is no, because the probability of 252 or fewer is equal to 0.9776, which is much bigger than 5%. So it's not anywhere close to this end of the number line. And that's the problem. It's got to be in this little tiny window here. It's got to be less than 5% away for it to be considered significantly low. And it's way too far away. It's much closer to the other end, which puts it in the significantly high range. Again, we're going to see this concept more and more. So if you don't quite have it yet, it's not the end of the world. We're going to see it more in the next chapter as well. So let's just do a quick conclusion with maybe one more little problem, and that will wrap up this section. So in a Pew Research Center survey of internet users, 3,732 respondents say that they use social networking sites, and 1,380 respondents say that they do not use social networking sites. What is the probability that a randomly selected person does not use a social networking site? Does that result suggest that it is unlikely for someone to use social networking sites? Okay, so now this one's a little bit tricky, because your gut is wanting to say, oh, I just need to divide these two numbers and I got my answer, right? Be very, very careful. That is not right. You want to look at it again. 3,732 respondents say that they use it. 1,380 respondents say they don't use it. So what's our sample size? What's our sample in this case? Sample's not this, a sample's not that, it's the total. So we need the total. So we got to add those two numbers up. And so that's going to be equal to what? 5,112, looks like. All right. So that's our sample for this problem. Now let's read the question again. What is the probability that a randomly selected person does not use a social networking site? So if they don't use it, that was the 1,380. So the probability of not is going to be 1,380 over 5,112. Let's see what that's equal to. So 0.2699, well, so that looks like it's going to round to 0.270. Does that result suggest that it is unlikely for someone to not use a social networking site? What do you think? Would that be significantly low? Remember, unlikely means it's a low probability. Is that a low probability? You should be shaking your head no. Remember, that low probability, that significantly low probability, is going to have to be less than 5%. So the answer is no, because probability of not is equal to 0.270, which is much bigger than 5%. So again, that 5% cutoff is really important. If as soon as it's bigger than 5%, then you know everything at that value and below has to be greater than 5% as well. So, All right, like I said, we're going to be seeing this more and more as we go. So if you don't quite get it yet, don't freak out. We'll see it again. The last part of this is just some takeaways. So the probability of any event is a fraction of decimal between 0 and 1 inclusive. So it could be 0 or it could be 1. That's what inclusive means. For any event A, the probability of A is between 0 and 1. That is, 0 is less than or equal to probability of A is less than or equal to 1. Probability of impossible event is 0. Probability of event that is certain to occur is 1. All right. A lot to absorb there, I know, but ask questions and we'll see it some more. Stay tuned.